everyone. Today I'm going to give you a presentation about advanced game controllers. And my talk will have the following four parts. First, I will give you an overview about the traditional game controllers. Then I will provide detailed analysis for most popular advanced game controller in the current market, namely the Wii Remote, PlayStation Move, and the Kinect. And I also will show you some alternative usage that have been developed based on these devices. And at the end, I would like to share some of my personal thoughts about future trends. So first of all, let's take a look at the evolution of game controllers over years. It's really important for us to have an understanding how the technology changed over time and what the industry focus is. So in 1972, the Magnavox introduced the first video home game console, and like this one, which is called Odyssey. It's an analog device based on printed circuit boards, and its controller very simple. It's only provide one-dimensional control on the TV screen with knobs on the side. And then in 1976, Fairchild's Channel F is released. Its controller is kind of like a joystick that time. The main body is a hand grip, and the triangular cap on the top provide an 8-way directional control. It can be also pull down, pull up, or push down as a fire button. And then Atari 2600 is released with a controller features only one button and one joystick. And soon after that, Magnavox introduced Odyssey 2, the second generation game video console, also have a one button, one joystick controller. But in addition to that, they also offer a full alphanumeric keyboard for programming and educational games. And then Mattel released the Intellivision, which features a quite different controller with a 12-button keypad on the top, and also a disc on the bottom which you can rotate around and provide 16 directional control. And similar to that, ColecoVision also have a keypad same controller, but instead of disc on the bottom, they use a joystick to provide directional control. And in 80s, a Nintendo Entertainment System was released, which is kind of revolutionary design of game controller, gamepad, with quite simple button layout with select and start and 2 action buttons, and they use a cross-shaped D-pad for directional control. And similar to that, Sega Master System is released soon after, and they have kind of similar button layout as the Nintendo controller, but instead of cross-shaped D button, they use a button shape, one square shape D button. And followed its popularity, Nintendo released the Super Nintendo controller, adding 2 more action buttons and also the trigger button on the shoulder, the L and R. And Neo Geo CD controller kind of using a different layout. They have 4 main action buttons, and instead of the D button, they use a joystick for directional control for some. And also, Sega Genesis is the first gamepad controller which twists the shape of the controller to fit hands better. And also, as the fighting game evolved over time, they require like more buttons to play fighting games. So therefore, you will see a 3-button version and a 6-button version. And again, Atari showed up with this kind of bulky controller. And actually, this is the last product they make for video games. It's always criticized for like non-necessary complex by adding this keypad below. And also, Nintendo introduced Nintendo 64 in 90s. This is the first controller have both a D-pad for direction control and a joystick. And also, it have a built-in rumble effect, rumble pack, which provide vibration feedback during the game. And the shape of this controller make it there are 3 ways to hold it and for different games. And in 90s, Sony also stepped into the gaming industry, providing their own video game console, PlayStation. And their controller is quite nice design and really easy to hold in hand. And their buttons are named after a color shape instead of letters. And also they introduced 2 more trigger buttons on the shoulder, L2 and R2. And many of you probably have seen this kind of controller in hotel rooms. And this is the first game controller have a built-in memory. So don't you don't need an additional device to provide games. You can play the game with the controller itself. And also you have the first one to have a memory slots to plug in additional games. And then follow the popularity of the PlayStation. Sony introduced PlayStation 2, and it's the first controller to have add on 2 more joysticks, providing more navigation and directional control on gamepad. And also added 2 more shoulder buttons, the L3 and R3. And very soon, Microsoft also decided to enter the gaming industry, and by introducing the Xbox, the layout quite similar to that Dreamcast. And also have 2 joysticks, but usually the original design is joked as the Xbox Fat because it's huge size. And Nintendo also released the GameCube, which is the first controller to use 2 different types of the joystick. And at the same time, there's button on the 2 action button here that also can actually control the camera during the game. And after that, Xbox shrink a little bit, and this controller also have the wireless capability with the Bluetooth technology. And then PlayStation 3 is released, and the controller didn't change so much, but there's a good thing about this controller is the first one to have the motion sensor built in. It has the accelerometer to detect motion and tilting. But still, it's kind of follow the traditional path as gamepad with buttons and joysticks. And beside these mainstream controllers, there are also some other kind of controllers over time. What's popular for a while but limited to certain game type, such as paddles, usually very good for providing one directional control along one axis on the TV screen. And a trackball, basically an upside down mouse. Its advantage is it can move as fast as you can move the ball. And also the joystick are usually for flight simulation games. It's really natural and intuitive, same as the steering wheel for racing games. And when you're little, you probably have played with leg gun, which is a pointing device and very helpful to play shooting games. And also the dance pad was quite popular for a while when the rhythm games was popular. And it's basically just put the buttons on a pad where you can step on instead you just use the hand. So with the variation of the controllers, these controllers just kind of popular for certain games. The mainstream is still the gamepad kind of controller with a device held in your hands and you play the game with your fingers. But the problem with that is it's good easy to play with, but sometimes it makes the game less engaging. Usually, player just play with game with your hands, and sometimes even just fingers or 2 thumbs. That's it. So, what the next generation of game controller will be? Maybe more buttons to improve your finger productivity, like this one, like a game keyboard in your hand. Well, definitely the answer is no. Actually, with when the technology advanced over years, and nowadays we have accelerometers, Bluetooth, a gyroscope, which all these enable for a change about game controllers. So the industry leaders have shown us the new approach with concept called motion control. So in 2006, Nintendo released the Wii Remote, and 4 years later, Sony and Microsoft joined in with their Move and Kinect. And this really marked the era of motion control has begun. So now I would like to go over one by one, provide detailed analysis about these advanced game controllers. So the first one, the Wii Remote, which is released in 2006. It's the first one to feature motion sensing, and it has built-in motion sensors to provide position and movement control. At the same time, it also has a built-in infrared optic sensor to provide pointing functionality. And also have a built-in speaker provide audio feedback. And they also follow the kind of tradition when you hold in both hands with the Wii Remote. It can function as a traditional gamepad with the D buttons and 2 action buttons on side. So let's go inside to look at what's the hardware. So besides the traditional button contacts on the one side, they have a motherboard, have a couple chips there. It features one Bluetooth chip and also a motor to provide vibration feedback, and they also have expansion ports for some add-ons. And this is the built-in infrared sensor. And all this is packaged in one shape, package. And not that complicated, but really introduce the gamers about the motion control. And also, it broader the audience base. It's broader audience base and welcome a lot of traditional non-gamers to this market. So how does it put all together and how does it work? Here's a video clip I will show you.
In the last year, one video game company has taken an innovative step towards a new interactive style of gameplay, the Nintendo Wii. But it's the Wii's controller. In an innovative step towards a new. The Nintendo Wii. Changing the industry. The Wiimote uses a combination of motion sensing technology. Inside the Wiimote, there is a speaker and audio amplifier chip. This allows for audible feedback from right inside. There's a in the last year, one video.
Just 1 second. It was working. Did your laptop work?
No.
I see I
Tested it out
tested.
this morning.
Yeah, I
Yeah.
tested before I started.
So maybe the connection got loose. Or...
In an innovative step towards a new interactive style of
But if you can hear it, just then.
Can you turn up the volume on the laptop?
The Wii Remote, or Wiimote, that's changing the industry. The Wiimote uses a combination of motion sensing technology
Do you want to start it again? So you can see from the
as well as a
beginning.
I
pointer
think they
system
can get it.
Okay.
to create a level of interactivity in games that was previously impossible. But how does it work? Inside the Wiimote, there is a speaker and audio amplifier chip. These allow for audible feedback from right inside the remote. There's also a standard memory chip, capable of storing up to 16 kilobytes of information. The most coveted chip inside of the Wii Remote is the accelerometer. This records the direction and strength of forces being applied on the Wii Remote. The data converter then converts these analog forces into digital data that can be sent to the Wii via Bluetooth. The directions the accelerometer can detect include front to back, or the Z-axis, side to side, or the X-axis, and up and down, or Y-axis. It uses these three forces to calculate exactly what direction a force applied to it is traveling. It can also detect bank and pitch. To find the pitch, it finds the force of gravity, which is always pointing down, and compares it with the angle it makes with the Wiimote. If the angle is acute, then it knows the Wiimote is tilting downward. If the angle is obtuse, then it knows the Wiimote is tilting upwards. The same applies to the bank. It measures the angle of gravity versus the Wii Remote and calculates its tilt. By combining these two values, we see how the Wiimote knows exactly which way it's being tilted. On the other side of the remote, we find a rumble pack. This creates physical vibrations in the remote that correspond with an event on the screen. The large chip in the center is a Bluetooth chip that's responsible for transferring information to and from the Wiimote and the Wii. The Wiimote has a chip for translating analog data, such as human speech, into a digital data stream. Basically, it acts as a microphone. On the bottom, there's a port for plugging in controller attachments. The entire system is powered by two AA batteries. Finally, there's an infrared sensor used to detect and translate signals sent to it by the sensor bar. Oddly enough, the sensor bar doesn't actually sense anything. Instead, it has two sets of 5 infrared lights that the Wiimote uses to triangulate its location on the screen. Because of the infrared filter on the front of the Wiimote, all it can see are the 10 lights from the sensor bar. When the lights from the sensor bar move to the bottom of its view, it knows that the cursor should be at the top of the screen. When the lights are on the top of the view, the cursor is placed at the bottom of the screen. The same applies to left and right motion.